we're starting to look at polynomials, and we're going to look at a couple of topics today. And this is one of those sections where by itself doesn't make a whole lot of sense, but fits into the big picture. So don't write this down. Just a quick reminder how to do long division. I think this will help. So we're going to take 243 divided by 7. So I put the 243 inside, the 7 outside. I'm looking for what times 7 will get me close to 24. That would be 3 times 7 is 21. If I subtract, I get 33. And 4 times 7 is 28. I subtract, I get a remainder of 5. So 243 divided by 7 is 34 plus 5/7, or 34 and 5/7. Okay, I'm not going to make you do that on test, just to help us get started. We can also do long division with polynomials. So I'm going to take 4x cubed plus 5x squared, subtract 11x plus 2, and divide it by x subtract 3. So the x subtract 3 is out here. My 4x cubed, etc., is inside here. And then what I'm looking at is the first term here and the first term here. 4x squared times x will give me 4x cubed. And 4x squared times a 3 will give me the 12x squared. I subtract, I get 17x squared. Subtract 11x plus 2, so 17x times x is 17x squared. Subtract 51x, and then when I subtract that, I get 40x plus 2. Keep going, and I end up with a remainder of 22. So when I took the 4x cubed, etc., divided by the x subtract 3, I got 4x squared, etc., plus a remainder of 122 over x subtract 3. Now just a quick little side note here. If we take a look at our original polynomial, and then take our x subtract 3, set it equal to 0, we get x equals 3. So if x equals 3, I'm going to plug that into the polynomial, p of 3, evaluate, and I get 122, which is the same as my remainder. No, it's not a coincidence. We'll see why soon. Okay, the remainder theorem. If you take a polynomial p of x divided by x subtract c, the remainder will always equal p of c. So a 0 of a function is a value of x that makes the function equal 0. So it's also an x-intercept. Math is truly amazing. And by the way, do you know what a polynomial is? The formal definition of a polynomial tends to look really scary. A sub n x to the n plus a sub n minus 1 x to the n minus 1, blah, blah, blah. Really, the idea with the polynomial is you have just one variable, these powers of x. Any of the exponents on the x are nice positive integers, so like an exponent of 5, an exponent of 4, an exponent of 3. No negative exponents on the variables, no fractional exponents on the variables, and then the coefficients are real numbers. So something like 3x squared plus 2x plus 1, a quadratic, that's just a second degree polynomial. The degree of the polynomial is the size of the biggest exponent. So this one's a fifth degree polynomial here. And I'm using a new mouse today, so this is a little bit weird. Sorry if it's confusing. Okay, so another quick example. I'm not going to make you do long division with polynomials, so to just kind of see roughly what's happening here. When I do this division, this time we get a remainder of 0. And so what I want you to notice, what that means is that if the remainder is 0, we've actually factored the polynomial, because this went evenly into this times this equals this. So our original polynomial, our third degree polynomial here, is factored into x plus 4, and x squared subtract 10x plus 10. And also, if we evaluate p of negative 4, we'll get 0, because that was our remainder, always equal the remainder. Okay, so oh, sorry, hit the wrong button there. Okay, so we know that we can actually factor the polynomial, that p of negative 4 is 0, and also that we've got an x-intercept, negative 4 is 0. Okay, factor theorem. There's a critical step. So a polynomial p of x has a factor, x subtract c, if and only if p of c equals 0. So that means if we divide in a remainder 0, we have a 0. Remember, a 0 is a value of x that makes the function equal 0. And also that we have a factor, x subtract c. And if we have a 0 of a function, then we know a factor. If we have a factor of a function, we have a 0, which is all very nice, but long division is really painful. So we've got a shortcut to long division that's called synthetic division. And what I'm going to do is pop over here a page and do this by hand so you can see what I'm doing. Okay, so what we're going to want to do first is just take the coefficients of the polynomial. Excuse my handwriting. So, oh. Okay, let's try that again. I don't know if this is going to work or not. What I'm doing is I'm taking the coefficients of the polynomial, the 1x cubed, the negative 6 from the x squared, the negative 30 from the x, and then the 40. And then I'm going to turn my division sign upside down. And here's the tricky part. Since it's x plus 4, I'm going to use negative 4 here. And then the way synthetic division works, I'll take the 1, I'll drop it all the way down here. Take the 1 times the negative 4, and then I'm going to write it here in my work area. So 1 times negative 4 is negative 4, and then I get to add, and that gives me negative 10. Negative 4 times negative 10 is positive 40. Add, and I get 10. And then 10 times negative 4 is negative 40. Add, and I get my remainder of 0. This looks really ugly, so I'm going to pop back over here to where I did it a little tidier. Okay. And then our result here, the 1, the negative 10, and the 10 form the remaining polynomial. We started with a third degree polynomial, so after we do our division, we should now have a second degree polynomial. It should always drop by 1 degree. So our remainder is 0. Here's our constant, our x, and our x squared term. So we get x squared subtract 10x plus 10 as a result of doing the long division, which is the same thing we got over here when we did it with the long division. So synthetic division takes up a lot less room, there's less to write down, and fewer those silly arithmetic mistakes we all make tend to creep in. So it's just a compact way to do long division. And just a note, it only works if you're dividing by x subtract c. So if we want to divide by an x squared, we'd have to do long division rather than synthetic division. Okay, let's skip over that again. Okay, so pulling some of this together, synthetic division is a quick way to divide a polynomial by x subtract c. The remainder that we get after we divide by x subtract c will always equal p of c. And if that remainder turns out to be 0, then x subtract c is a factor, c is a 0, and then we also have an x-intercept as long as c is a real number. And we'll get to that in a couple more sections from now. Okay, a few more examples here. So if we have 4x cubed, subtract 10x squared, subtract 8x plus 6, I grab the coefficients first. I'm dividing by x subtract 3, so I'll take the positive 3 here. And the way synthetic division works, drop the 4. 4 times the 3 is the 12. Add to get 2. Take that 2 times the 3, put the 6 here in our work area. Add to get negative 2. Take that result, multiply by the 3 again to get negative 6. Add, we get our remainder of 0. So we know p of 3 is 0. 3 zeros an x-intercept of the polynomial. And the polynomial can be factored to x subtract 3, 4x squared plus 2x subtract 2.